Okay, so for the displacement is a distance that you have traveled or moved from the origin over a period of time. The way that we are denoting displacement is going to depend on the function, but so for right now, if it's s of t, or displacement over time, and the possible units that we'll use would be if you had like meters, for example. So the velocity, you get the velocity from taking the rate of change of the displacement, and that velocity will occur over time as well. The notation for velocity, we can use v of t as one of them, or s prime of t, which is the derivative of the displacement. So you need to be aware that if you see v of t, that means the v of t was the derivative of your first displacement function. Although there's no prime there, you need to know that. And the units, going along the same lines, would be, for example, meters per second. The acceleration, we get the acceleration from taking the rate of change of the velocity. So the notation that we would use for acceleration would be, if we had your original function, your acceleration you get from taking the second derivative of that displacement function, or from taking the first derivative of the velocity, right? The function before was velocity, which is actually the derivative of the displacement, or you could use acceleration over time. And again, if you see acceleration over time, you need to know and be aware that means finding the derivative of the displacement, then the derivative of the velocity. And the possible units, because it's still over time, would be meters per second squared. So if this is our function, the first thing you want to do is you want to find where the slope has a value of 0. So where would the slope be a value of 0 for this function? Okay, 2 and 6. And you might think at 0 here, but the only reason the function stopped was because it's distance time and we can't have a negative time. So really this function does go down like this, but we just don't draw it, so it's not a turning point. It's not a max min. All right, so we have those. Let me just erase this. So if our y values have to be positive because of the positive slope, it has to go up. So when we start coming down, those are negative y values, so then we know that this has to come negative. And just like before, there is a turning point. There is a point from which those get steeper and steeper to getting flatter, and flatter to get along there. Because there's a turning point in here, this has to hit a max or a min. Those are going to be green positive slope, y values. So there's your velocity graph. Now you have to do acceleration, which you just do the same thing, but you do it for the green one. So can we find an x-intercept? Yep, at 4. Now look to the side here. These are all negative, so we know this will go down. Once we hit the turning point, we know those are positive, so then it will go up. Look, it's magic. Ooh. Did we do it right? Ah. Yay, we did it right. So the green is the velocity, the blue is acceleration, and you need to look at the rate of change of the one before. That's how you tell the motion of the particle. Okay, you just look at the sign of each, multiply them, and that will tell you what it's doing. And now here's the example we're going to try. So when you're finding the acceleration and the velocity, you just take the derivative of the first, and then you take it again of that. And then for part B, when the rocket is at rest, that's when your velocity equals 0. So if you solve for t, you get t of 3 seconds. So the rocket is at rest at 3 seconds. Now for part B, this is a good question, is to say, okay, at 4 seconds, is the rocket speeding up or slowing down? And if you go back to what we had before, this one right here, if we multiply the two, we can say if it's speeding up or slowing down. So we have to find each of these and then just multiply them. So if we go back, so for part C, whoops, went too far. So for part C, we're at 4 seconds. Can we figure out what the velocity is at 4 seconds? And the acceleration at 4 seconds? So let's substitute it in. We have negative 10. Is everybody talking because they've already done it? What's the A of 4?
It's negative 10.
Negative 10. It will always be negative 10. And if we multiply B of 4 times A of 4, that's negative 10 times negative 10. We get positive 100. What does that mean? Speeding up. So you write therefore, at 4 seconds, the rocket is speeding up.